Welcome back. Now we have our crosshairs drawing to the screen. But there's a problem. Whenever we shoot, the bullet shoots in the direction of the barrel and it doesn't go towards our crosshairs. In this video, we're going to aim the bullet blast toward the crosshairs so we shoot wherever we're aiming. Now don't worry that our gun is not following the direction of our crosshairs. We'll fix that very soon in a future video. For now, let's just get our gun shooting in the correct direction according to our crosshairs. Let's get started. Now in shooterCharacter.cpp in our fire weapon function, just after our check for muzzle flash, here we begin setting up our variables to do a line trace. And then we spawn our impact particles and spawn our beam particles based on that line trace. We're going to go ahead and comment out everything from our hit result all the way down to our if check for beam particles. So we're not going to use the hit result or the start and end locations, the beam end point, our line trace, our check for blocking hit, our check for beam particles. All of this will be commented out because we're going to do this slightly differently now. What we want to do is, instead of line tracing from the barrel socket at the tip of the rifle, we want to line trace from the screen position of our crosshairs straight out into the world. Now to do that, we need the screen location of our crosshairs, and we're going to use that to get the location of our crosshairs in world space. But first, to get the screen location of our crosshairs, we need to know the size of our viewport. So let's create a local F vector 2D called viewport size. And to get the size of the viewport, we need to use the inherited gEngine variable. So first we'll do an if check to see if gEngine is valid. Now if you hover over this, it's a uEngine object. It's the global engine pointer. This is what holds the viewport. We also need to make sure that the viewport is also valid. So we're going to check gEngine and access the game viewport. If those are both valid, then we can access gEngine to get game viewport, and from game viewport we can call get viewport size, and this takes in an F vector 2D reference called viewport size. We're going to pass in our local variable that we called viewport size. It's passed in as a reference that's not const, which should tell you that get viewport size will fill in the X and Y for viewport size with the current size of the viewport. Next, we need to get our crosshairs location on the screen. So we'll need to create an F vector 2D, and we'll call this crosshair location. And we'll initialize its X and Y. The X will be viewport size dot X divided by 2 dot F. And the Y will be viewport size dot Y divided by 2.F. Now remember, we raised the crosshairs by 50 units. So we're going to take crosshair location dot Y and subtract off 50.F, just like we did in the HUD blueprint. Now that we have the screen location of the crosshairs, we need to get the world location of the crosshairs. And to do that, we can use a function from gameplay statics called dproject screen to world. So it's gameplay statics dproject screen to world. Now it needs a player controller, and gameplay statics has a function called getPlayerController, which will always return a player controller for the pawn. So we're going to use gameplay statics getPlayerController, and getPlayerController takes a world context object. We'll pass in this, and it takes a player index, and we'll use 0 since we're only going to have a single player in this game, so its index will always be 0. The next argument is an F vector 2D for the screen position. This is the screen position that we want to deproject from screen space to world space. We're going to use crosshairs location for this. I'm going to hit enter to continue this on the next line. so we're going to use crosshair location. Next, dproject screen to world takes two F vectors, one for the world position and one for the world direction. Now notice, these are not const, they're just passed in by reference, which should tip you off that dproject screen to world is going to fill these in with information. And that's going to be the world position and world direction of our crosshairs screen location. So let's create some local variables just above here for the crosshairs world position and world direction. So F vector crosshair world position and F vector crosshair world direction. And we'll pass these in for the next parameters. Crosshair world position and crosshair world direction. Once this function gets called, crosshair world position and crosshair world direction should hold the information for the crosshair's location in world space, as well as its direction, which should be pointing directly away from the screen or directly away from the camera. Now, dproject screen to world returns a Boolean, and it's true if the deprojection was successful. So we can store the result from this function call in a local Boolean. Let's call this bool b screen to world. And we'll assign that the value returned from dproject screen to world. That way we can check this Boolean to see if the deprojection was successful. So we'll do that on the next line, if b screen to world. Now if this was a success, we now have the location of the crosshairs in the world and the direction pointing outward away from the camera. We can perform a line trace from this position in the direction of crosshair world direction. So we'll start off by creating our hit result, F hit result, and we'll call it screen trace hit. We'll create the start location for the line trace, const F vector start, and we'll initialize this with the crosshair world position. We'll create an F vector for the end of the line trace, const F vector end, and it's going to be crosshair world position plus crosshair world direction times 50,000. So we're starting off with crosshair world position, and then we're adding crosshair world direction times 50,000. This is similar to how we calculated the end previously, only we're starting off at the crosshairs position instead of the barrel of the gun. Now we're going to spawn the smoke beam, so we need the beam end location as well. We're going to create an F vector for the beam end point. And we'll first set it to the end vector. So if we don't end up hitting anything with our line trace, the beam endpoint will still just be the line trace endpoint. But if our line trace is successful, then we can set this to the impact point from that line trace. Next, we can perform our line trace. Remember, the function belongs to the uWorld, so we're going to use get world line trace single by channel. Now it takes our hit result, we called it screen trace hit. It takes the start vector, we called that start. It needs the end vector, which is end, and the collision channel. We're going to trace for visibility again. So E collision channel, ECC visibility. Now since I have the font size really large so you can read this on your screen, I'm going to go ahead and move some of these parameters to the next line for readability. I'm going to do the same thing for this call to dproject screen to world. I'm just going to go ahead and move these parameters so they're all orderly and you can see them all. Now after we perform the line trace, we can check with our screen trace hit result to see if we got a blocking hit. So we'll say if screen trace hit dot b blocking hit, and if we did get a blocking hit, we can set the beam endpoint to the location of the blocking hit. So beam endpoint equals screen trace hit hit.location. We can also spawn our impact particles at the location of the hit, just like we did before. So we'll check to make sure impact particles is valid, and we can spawn them with uGameplay statics spawn emitter at location. Now the first argument is the world, so I'll pass in get world. I'll stick it on the next line. Next, it wants the particle system. We're going to use impact particles. And finally, it wants the location, so that's going to be screen trace hit dot location, like so. Now, whether we get a blocking hit or not, we still want to spawn the beam particles. So after this if check, we're going to check to see if our beam particles are valid. If beam particles. And then we're going to use the code that we use to spawn the beam. So we can scroll down here and see if beam particles. We can highlight this code and come back up here and paste it in. And what we did was we created a local uParticle system component called beam, set that equal to gameplay statics spawn emitter at location. I'll go ahead and just stick all the arguments on different lines for this so we can see it. And if beam was valid, we set that vector parameter called target to the beam endpoint. Okay, so since this is all a little bit complicated, let's put some comments in here. So up here where we created the viewport size vector, I'm going to comment this and say get current size of the viewport. And for crosshairs location, I'm going to say get screen space location of crosshairs. Now just before we call deproject screen to world, I'm going to comment get world position and direction of crosshairs. And then for this line, if be screen to world, let's comment was deprojection successful. So if the deprojection was successful, we first set the beam endpoint to the endpoint of the trace. So we'll comment this and say set beam endpoint to line trace endpoint. And then for line trace single by channel, we'll comment this and say trace outward from crosshairs world location. Now in this check to see if we got a blocking hit, we'll comment this and say, was there a trace hit? If so, we set our beam endpoint to the trace hit location. So we'll comment this and say, beam endpoint is now trace hit location. And finally, if impact particles, we spawn the impact particles. That's self-explanatory. And then if beam particles, we spawn the beam particles. So that's pretty self-explanatory. So now our code has some comments that show us what we're doing. Let's go ahead and compile this. Okay, back in the editor, we're going to hit play and we're going to just fire. And we'll see that the impact particles are spawning at the hit location in the world corresponding to our crosshairs. Now we can shoot and be confident that we can hit what we're aiming at. So that concludes this video. In this video, we got the screen space location of our crosshairs, deprojected it to world space, and then performed a line trace straight outward from the world space location of our crosshairs. We then used the hit result from that line trace to set our beam end location and our impact location for the impact particles. In the next video, we'll continue to fine-tune our aiming mechanics. See you in the next video.